This is where we were in the last video of this exercise. Now we want to write this in polar form. Now remember that when you have the complex number in exponential form like this, it's generally presented as z is equal to r e to the j theta. We're using j, but you may also see I being used by persons in books, online, and so on. Alright? So here, theta is the angle. And once you see pi or something about pi, some number times pi or pi divided by a number, you know that the angle that they're dealing with is in radians, not degrees. Alright? Once you see that. Now, here, we want to write it. Write down the number in polar form. You know that the polar form, remember, it's A that we're doing now. The polar form, right, is equal to r cos theta. Pardon me. Let me turn the alarm off this phone and then continue. Get rid of this alarm. Okay, good. It's r cos theta plus j r sine, oh boy, all right, sir. Sine theta, right? So that's what we have. So in this case, r is 4. You can see that r is equal to 4. And theta is equal to pi over 3. And it's radians, right? Definitely. Once you see the pi. Alright, so the polar form, you said, is equal to 4 cos pi over 3 plus j 4 sine pi over 3. Alright? It could also be written as 4 open bracket cos pi over 3 plus j sine pi over 3. Alright? Could be written that way with the brackets. Alright. So, that's what we have. Now remember where the sine and cos come from, in case you didn't remember, is that when we have the complex number in a circle, r is the radius of the circle. Alright? So if we make it larger, we have the complex number. It goes out here a certain distance. Let's call it x, and it comes up here a certain distance. We call that y. We know that this is theta, and cos theta is adjacent x over the hypotenuse, which is r. So when you transpose, you get x equal r cos theta, and then the sine of theta, sine theta, is going to be the opposite, which is y over the hypotenuse r. So it's equal to y over r, y over r. So when you transpose for y, you get y is equal to r sine theta, right? So in our case, r is 4. It's 4 cos theta, which is the horizontal axis, the real axis, plus j r sine theta. where y-axis is the imaginary axis. Our r is 4 sine theta, which is in this case pi over 3. Alright? So that's the polar form. Now, we want the rectangular form. So we had this part done. Good. The rectangular form is where we're at right now. Part B. Now, I'm going to erase the one at the bracket and make the other one remain. Here, 4 cos pi over 3. We want to find out what that is. We're going to use our calculator. I want to use this calculator. Let's put it in scientific mode. We'll see the sine, cosine, cos, and so on. In radians. Make sure your calculator is in radians when you're dealing with radian. Alright? If you forget to put it in radian mode, you're going to get wrong numbers. So here now, we have pi. Well, with this calculator, I have to go to this pi, right? Divided by 3 equal that. And cos. Alright, the cos of that is 0.5. So we have z equal 4 times 0.5. Z is equal to 4 times 0.5 plus j 4 times. Alright. Now, we're going to deal with that part of it now. J part. So here now. Again, we have pi over 3 equals, and then sine that. Sine 0.866. So we have 0.866. Now, we finish that off by saying z is equal to 4 by 0.5 is 2 plus j. 4 by 0.866 is what? Let's calculate that. And remember, you know, I had asked you, it's not this calculator hour. Remember, I had asked you to work it out from the previous video. So you should have worked it out. Alright? This 0.866 multiplied by 4 equal 3.464. Alright. 3.464. So that's what we have there. Alright. 3.464. So that is the complex number in rectangular form. Alright. Let me just write them up here. So let me just write it down. Oh, I don't want to erase the z part. The original thing, the original question we got. Let me move it out of the way. Oh no. So the answer for this part was z equals 4 cos pi over 3 plus j 4 sine pi over 3. Alright? And then this part here, the answer was z equal 2 plus j 3.464. Okay, good. Now, let's look at the cube roots. We're going to find the cube root of Z and write them down. So we're going to find the cube root of Z. Let's do that in the next video. No?